Alright, so what I'd like to do with you today is take you through a couple of stoichiometry problems, just as more examples. And so in this video I'll show you the solution to example problem number 4 from Stoichiometry practice page number 2. And hopefully you've got this problem in front of you. If not, it's right here on the screen, so you can copy it down really anywhere. And you can do the same work that I'm about to do here on any scrap piece of paper as well. So what we did in class up till now is start to look at how stoichiometry problems are solved with 4 steps. Basically the idea that we take any equation and balance it. We convert the starting amount into moles if it's not already there, and usually we start in grams or liters and convert that to moles, but we could also start in atoms or molecules or formula units. The next step is to multiply by a mole ratio of some kind, which will relate the two substances that are to be solved in the problem to each other. So in any mole ratio in stoichiometry, we're going to connect the target substance or the ending substance that we're trying to find an answer for to the starting substance, which is the one that you're given an amount for at the beginning of the problem. And then after you've solved with that step in number 3, you should have canceled out all the moles of the substance that you began the problem with and be left with just moles of your target substance or your ending substance. And then finally, usually we don't want the ending substance in moles. If we do, then you're done. But more often or not, we're going to be solving for the target substance converted into grams or liters or some other such unit like that, including possibly atoms or molecules. So what I'd like to have you do then is, with those steps in mind from your notes, is go through question number 4 with me. And I'm going to do it here on the previous page so you get a little more space to write. So it asks us how many grams of aluminum would react completely with 17.50 grams of copper 2 chloride according to the following equation. So hopefully you look at this and recognize it as a single replacement reaction. And what we want to do first, of course, is balance the equation. So to get this equation balanced, I'm not going to spend a lot of time going through the balancing, but in the end, we'll need to get 6 chlorines on each side. So I put a 3 on the left, a 2 on the right. And that means that I need a 2 in front of my aluminum on that side and a 3 on the other. So there's my balanced equation. Pretty simply 2, 3, 2, 3. The next step, again, is to take the starting amount and multiply it in such a way as to convert it to moles, or just simply to convert 17.50 grams to moles. So I'm going to set up my little box here to organize my math. And you can use these if you wish. Some people use just sets of parentheses, but whatever you like to do. And I'm going to take my 17.50 grams of copper 2 chloride, CuCl2, and convert that to moles. So I've already got it in grams. If it were in moles, I could skip ahead to the mole ratio step, but because it's not, we're going to go ahead and convert it here into moles. And so on the top, 1 mole of copper chloride. And on the bottom, we need some equality statement to make this box true. 1 mole of copper chloride, copper 2 chloride, contains some number of grams of copper 2 chloride. And in a moment, that will allow me to cancel out grams of copper 2 chloride. So you can go to your periodic table and add up CuCl2 and take it to at least 1, if not 2 decimal places. And you should find that when you add that up, it comes out to be about 134.5 grams of copper chloride. At this point, I could plug it in my calculator and take 17.50 divided by 134.5. Or, if you want to be very complete, 17.50 times 1 divided by 134.5. But in the end, in any case, our answer would be in moles because these grams cancel out, and I'm left with moles of copper chloride. Now, that's not the end of the problem, so we're going to go ahead and add on the next step before we start plugging it into our calculator. Generally speaking, if you can stand to wait till the end to plug it into your calculator, you'll be a little bit better off because people start rounding more than once when they're solving it in the calculator step by step. And when you round and then round again and then round again, sometimes you end up off substantially, whereas if you just punch it in the calculator at once at the end, you won't make as many rounds and you'll find that your answer is more precise. So the next step is to use our mole ratio, and that's going to let us relate the substance that we're trying to solve for, which is aluminum. Notice again in our problem, we want to kind of look for that question within the question. How many grams of aluminum? That's really the question that's being asked here. And so in the end, we're going to want something to get us to grams of aluminum. But all we know at this point, or what we need to know at this point, is that aluminum is our target substance. Okay? Again, that's my target. That's where I'm trying to go by the end of this problem. And I'm starting this problem with copper chloride. 17.50 grams of copper chloride. As usual, when we're doing conversions, whatever units you have in your box on the top here, in this case moles of copper chloride, that unit, moles of copper chloride, will come down and to the right. So I'll bring that down, moles of copper chloride. And again, that was my given substance that I started the problem with. And again, if we skip back to our mole ratio here, remember it's always the starting substance that you're given at the beginning going on the bottom in our mole ratio, and the target substance that you're trying to get on the top. So moles of copper chloride on the bottom, and on the top I'm going to do moles of aluminum, since that's what I'm trying to solve for. The numbers that go in front of those, remember, are x and y, or whatever whole numbers your balanced equation gives you for coefficients. So in this example, x and y, the coefficients on my middle step, will be, for aluminum, the 2 that we find is the coefficient in front of aluminum, so that 2 comes down here, and the 3 for copper chloride comes down and goes in front of copper chloride. What this is saying in that ratio step then is that in this reaction 2 moles of aluminum are needed for every 3 moles of copper 2 chloride. They react in a 2 to 3 ratio. We're not saying that 2 moles of aluminum equal 3 moles of copper 2 chloride, but we're saying it as a ratio, so 2 moles of aluminum for every 3 moles of copper 2 chloride. And really, we could always substitute in with these ratios and with these steps for every 1 mole of copper chloride for every 134.5 grams of copper chloride, or vice versa. So it's kind of the same way as saying equals, but without saying really equals, because obviously aluminum and copper chloride aren't the same. So copper chloride is going to cancel out moles, cancel out with moles. Careful you don't cancel out the numbers. And then our last step in stoichiometry here is to convert the target substance, which in our problem is aluminum, into whatever units we like. We're already in moles. In this problem, we can convert moles of aluminum into grams or liters or whatever we'd like. Well, liters is kind of unrealistic because that's for gases, and aluminum is probably not a gas. But the question tells us very clearly here how many grams of aluminum. So in this problem, we're going to solve for grams of aluminum by saying that for 1 mole of aluminum, there are, if I go to my periodic table, around 27 grams of aluminum. And by doing that, my moles will cancel out. In the end, of course, the final unit in this top right box should be the unit that we're looking for if we did everything correct. And that's why we label things very carefully throughout stoichiometry problems, so that in the end, my grams of aluminum unit in the top right corner of the box here is exactly what the problem's asking. How many grams of aluminum? Done. Okay. Now, we're not quite done, of course, because we need to punch it into our calculator. And so as you do that, be really careful that you're using parentheses or grouping terms. We want to put our numerator, multiply all those together, divided by the denominator, multiplying all those together. And whether you leave the ones in there or not, some people leave them out, some don't, you should get an answer from your calculator in the neighborhood of 2.34 grams of aluminum. Okay, 2.34 grams. Now, as we go back to the beginning of the problem, 17.50 grams of copper chloride had 4 significant figures, and my mass down here for copper chloride off the periodic table had 4 significant figures. But in the end, I only used 27.0 as my aluminum mass, and that has 3 significant figures. So that forced me to round off my answer to 3. If you went to the periodic table for aluminum and used a more precise number with more decimal places, then you can round your answer off to have maybe another decimal place and a 4th significant figure. But this is probably good enough for us right now. Anyway, 2.34 grams of aluminum would be needed to kind of match up with the 17.5 grams of copper chloride in this reaction. And what we're saying then is that those two amounts, in theory, would run out at the same time. It's as if you've planned the reaction so that the aluminum that you put in and the copper chloride that you put in would react or be used up at just the same moment. Typically, we don't try real hard to do that in a chemical reaction, but if we could, this is how much it would take. It also turns out that this copper chloride is very likely going to be formed into a solution by dissolving it into water. So you would take those 17.5 grams and dissolve them in some kind of water to make a solution, and then react that with the aluminum and so on. But very simply, in this problem, we're not trying to get too close into those sort of details. We just need to know how much aluminum it would take to use up that copper 2 chloride or to react completely with it. And by solving it through stoichiometry, we've gotten to our answer, 2.34 grams of aluminum. So that's example problem number 4. I'll make a video for problem number 6 yet, and you can watch one or both of those to help you out. Problem number 6 goes back to using of liters in volume again in a stoichiometry problem at standard temperature and pressure conditions. So you can watch problem 6 if you have time or would like another example. Otherwise, I'll see you next time I see you.